All right, in today's video, we're going to be talking about 2.6, which is the conclusion of chapter 2. It is radical equations in one variable. So remember that test 1 will open up on the 22nd and be closed on the 28th. So you have 7 days to get your test in. The um, practice test, though, I have opened on the 19th. So it'll open up 3 days before the test will. The practice test is not a grade, but it will prepare you for what is to come on the actual test. It's like your review part. You will have 2 hours to complete the test. So make sure when you start it, there is no stopping. So make sure you have at least a 2 hour window. There's only 20 questions on there, so it really shouldn't take you full 2 hours if you know your material. If not, though, you do have the 2 hours there. It is a lockdown browser, so if you haven't already, make sure your computer software is up to date and can take the lockdown browser. Again, I'm not adjusting the dates. Some have reached out and said that they're working on that, so make sure that is taken care of prior to that. Other than that, that will pretty much be the test on Blackboard on the week that the test opens up. There will be a section for you to upload your work. Make sure you do so. Failure to upload your work, you will get a 0 on the test. So I need to see the work for your test. If you have any questions on that, again, always feel free to reach out, ask, and I'll definitely assist with that. Uh, but anyways, so to wrap up chapter 2, we're going to talk about how to solve radical equations, and then you pretty much have just about any type of equation that can be done. You pretty much now know how to solve them all before we move on to chapter 3 after the test. Also note that on the week of the test, you do have 4 new sections that you need to keep up with. That's also due that Sunday as well. So make sure you're balancing your time wisely of the week of the test. All right, so we're going to be in 2.6 again, radical equations in one variable. I do have one example that I want to do that's not in the book. We'll call this example 1. It is the square root of 4 minus 3y equals -4. I just couldn't find one this easy in the book, but I want to make sure you had an easy problem to look at as well. To solve radical equations, the first key is to make sure that the radical is isolated. So the square root here, there's nothing being added, multiplied, subtracted, divided of it. It's all isolated. And then you can get rid of the radical. So the opposite operation of square rooting something is to square it. But of course, what you do on the left, you must also do on the right side. So then from there, you would then cross out and cancel, and you would have 4 minus 3y equals 16. After this point, you then just simply just solve. So minus 4, you get -3y equals 12. And then you would divide by -3, and you would get y equals -4. Now, with rationals, we had to make sure that whatever the value of x was, what couldn't make 0 a denominator. With radicals, you pretty much have to check every answer you get to make sure you don't get a negative inside the radical, but also make sure you get a true statement. So for instance, if I take -4 and I plug it in here, so let me do the check. So you do have to do this, or you'll end up getting the wrong answer because you got an answer, but it doesn't work. So we'll say this is 4 minus 3 times -4 equals -4. So I see that this is 4 plus 12. So that would give me 16, which will give me 4, which is not -4. So even though it gave you a real number, it did not give you a true statement. So this would be a empty set or no solution. So do watch out for this situation because it does happen. It doesn't happen a lot, but it does happen, especially if you end up with multiple answers. One or two of them could be not possible. All right, so again, I couldn't find one in the book that looked like this, so I kind of made this one up so you had the evidence. All right, so let's go now back to the book on page 144. This will be number one that we'll do, and this was given to us as square root of 4 minus x equals 2. So before I can square both sides, I must isolate the radical. So I'm going to add x to both sides. So I get the square root of 4 minus x equals x plus 2. Again, I like to keep it in standard form. Now I can square both sides. The square root and the square cancel. I'm now left with 4 minus x, and this is x plus 2 times x plus 2. Biggest mistake I see students make is try to distribute the square, but in reality, you need to fold it out. So this would be x squared plus 2x plus 2x plus 4. Combine like terms. So you get x squared plus 4x plus 4. Again, now see this is a quadratic. So when I get set equal to 0, so I'm going to subtract 4, add x, add x. This gives me 0 equals x squared plus 5x, and this happens to cancel out. I now see this as a greatest common factor situation. So this is now going to be 0 equals, I'm going to fact, I see that they had the greatest common factor of x. So therefore, I'm left with x plus 5. I'll set these both equal to 0. And therefore, this would be x equals negative 5. So I get x equals 0 and negative 5. So now all we got to do is just check it. So I'm going to quickly check 0. So this will give me square root of 4, which is 2, minus 0, which is 2. So x equals 0 is an answer. Check negative 5. 4 minus negative 5 will give me 9. Square root of 9 is 3. And then plus 5, right? Well, let's do this one. Okay, so that'd be 4 minus negative 5 equals 2. That's a positive, so that gave me 9, which is 3. This is a positive, so that'd give me plus 5, which is 2. So 8 does not equal 2. So my only answer here would be x equals 0. So again, always making sure you're checking that it works out. All right, let's definitely do a few more. Let's look at number 9. Number 9 is the fourth root of 2x plus 3 equals negative 1. So regardless of what kind of radical it is, you always want to make sure you isolate the radical, which in this case it is. So it's nice and isolated. So to get rid of a square root, you would square it. To get rid of a fourth root, you would just raise it to the fourth power. All right, so same concept. So then we cross out, so we get 2x plus 3. Negative 1 to the fourth power would actually just be positive 1, because negative 1 times negative 1 is 1, times negative 1 is negative 1, times another negative 1 will give me back to positive 1. I'd finish this out, so I'm going to subtract 3. So I get 2x equals negative 2, divide by 2, and I get x equals negative 1. We check it. So the fourth root, man, that looks really bad. Hold on. Check. Let's put it over here. Fourth root of 2 times negative 1 plus 3 equals negative 1. This will give me negative 2 plus 3, which is 1. The fourth root of 1 is 1, but the 1 does not equal negative 1. So in this case, there is no solution. Empty set. However, they make you write it out. All right, so again, always checking to see if it works. All right, let's look at number 12. Number 12, it gives you the square root of 5x plus 5 equals the square root of 4x minus 7 plus 2. I always tell my students when we do a problem like this is probably the hardest type that you will ever get. And it's not that it's hard, it's just very time consuming. This right here will be at least half a page of work. Just pre-warning you now. All right, on a problem like this, there's no way to isolate the square root. So however you like to deal with it, you can have both square roots on the same sign or opposite. It really doesn't matter. I just keep it like this because there's no point any other way. So I'm going to get rid of one of the radicals. So since one of the radicals is isolated, I'm going to square it. And that means I have to square the other one. Now, this is nice. This just goes away. This is 5x plus 5. What's not nice is that this is a binomial square. Technically, you have square root of 4x minus 7 and a positive 2. So this means this is the square root of 4x minus 7 plus 2 times the square root of 4x minus 7 plus 2. So you have two of those. You can't just distribute the square. So then with that said, I'm going to work it out. Square root of 4x minus 7 times the square root of 4x minus 7 is actually just 4x minus 7 because the square roots cancel each other out and you're left with just the radicand. Then you're left with square root of 4x minus 7 times 2, which will give you 2 square root of 4x minus 7. And then 2 times that would give you another one. And then 2 times 2 would just give you 4. All right, so now to kind of clean this up, don't necessarily need this in parentheses. I have 2 of these. So I now have 4. I have 2 that have 2 each, so I have 4 altogether. All right, now I'm going to try to combine like terms and isolate the square root. So I get 4x. I can combine the minus 7 and the plus 4, so that gives me 4x minus 3 plus 4 square root of 4x minus 7. So you cannot combine this 3 and 4, so do watch out for that. We'll go ahead and subtract the 4x and add the 3 to both sides. So I now get x plus 8 equals 4 times the square root of 4x minus 7. Now I'm going to divide both sides by 4. I'm going to divide each one individually. And I'm going to continue my work over here. So I now get x fourth plus 2 equals the square root of 4x minus 7. Now at this point, I now have the radical isolated, so now I can square this again. So now when I do that, I get x fourth plus 2 times x to the x, I say x to the fourth, x divided by 4 plus 2. This would cancel, and I'm now left with 4x minus 7. Distribute, so I do get x squared over 16 plus x half, because 2 times 1/4 would be a half, plus x half plus 4 equals 4x minus 7. Combine like terms, so I get x squared over 16. 2 halves now make a whole, 4x minus 7. And then I see I have a square root, so I'm going to subtract everything over. Not square root, I have a square. I need to make sure it's equal to 0. So I have x squared over 16 minus 3x plus 11 equals 0. Now at this point, I don't know why I put a 6 here. I don't want to have to deal with the 16, so I'm going to multiply everything by 16. And when I do that, I get x squared. What's that? 16, 32, 48 minus 48x. I'll bring out a calculator for this one. 16 times 11, 176 equals 0. So now I got to come up with two numbers that multiply to 176 but add up to negative 48. All right, so let's think. 176, that looks like 176. 13 times 13 is 190. No, it's 169. So 13 times 14? Nope, too much. 12 times 15. No, 11 times 16. Okay. Okay, so that's 11 and 16, but that only gives me 27. I need 48. Okay. We gotta get further apart. Let's do this. 176 divided by 2. Nope. All right, let's try 176 divided by 3. Nope. 176 divided by 4. There it is, 4 and 44. All right, so here's 4, here's 44. They would both have to be negative to add up to a negative 48, but then multiply by a positive 176. So that means that x equals 4 and x equals 44. Ran out of room, but you would set those equal to 0 and add both sides. All right, so now we just got to check it. So I'm going to quickly put this in. So 4 times 5 is 20 plus 25. This will give me 5. 4 times 4 is 16 minus 7 is 9. That would give you 3. 3 plus 2 is 5. All right, 4 works. 44 is not a quick thing I can do in my head. So let's see. 44 times 5. Ooh, that's 55. Plus 5 is 225. So that would be 15. So 15 on the left. So then we do 4 times 44 minus 7. 169 is 13. Plus 2 is 15. All right, 44 happens to work too. So both of those would be part of your answer. So as you can see, it is, I wouldn't call it hard, but definitely a lot involved. And it's probably one of the hardest ones you'll have to do. So it doesn't get much harder than that. So as long as you can follow that and mimic that again, you'll be just fine. But it definitely is a time-consuming problem. All right, let's look at number 13. Not so as in depth, but still just as good. So we got the square root of x plus 10 plus 1 equals x minus 1. So in this case, I'm going to subtract 1 on both sides because I need to isolate my square root. So I get x minus 2. Now I'm ready to square it. So it gives me x plus 10 equals x minus 2 times x minus 2. Pull that out. That gives me x squared minus 2x plus 4. Then I get x plus 10 equals x squared minus 4x plus 4. Now I see it's a quadratic. So again, I'm going to set it equal to 0. So subtract x here, subtract 10 here. I get 0 equals x squared minus 5x minus 6. So this would be 2 and 3. Nope. 6 and 1. This would be negative. This would be positive. So that multiplies to negative 6, adds up to negative 5. That means x equals 6 and x equals negative 1. We check it. Negative 1 plus 10 is 9. So square root of 9 is 3. So 3 plus 1 is 4. But negative 1 minus 1 is negative 2. So that's out. Try 6. 6 plus 10 is 16. I guess it's 4. 4 plus 1 is 5. 6 minus 1 is 5. So in this case, x equals 6 would be my only answer. Always check. All right, so let's get into ones that look complicated but aren't so bad. Let's look at number 24. This is 2x minus 1 raised to the 2/3 equals x to the 1/3. All right, technically these are radicals just written in rational exponent form, but the goal is still to get rid of fractions. So what I'm going to do is if I'm raising it to the 2/3 and I want to get rid of a fraction, I'm going to raise it to its denominator, right? Because we know a power to a power would multiply and the denominators would cancel. What I do to one side, I must also do to the other. So now I'm left with 2x minus 1 squared equals x to the first power. So therefore, we got a little bit easier of a problem now. So now I got 2x minus 1 times 2x minus 1 equals x. Pull it out, so you get 4x squared minus 2x plus 1 equals x. Therefore, I get 4x squared minus 4x plus 1 equals x. Subtract x since I'm dealing with a quadratic. So I get 4x squared minus 5x plus 1. And then this is kind of the t-chart. Still going to be an x. So now what multiplies to 4 but adds up to negative 5, well, that'd be negative 1 and negative 4, right? So that would multiply to positive 4 and then add up to negative 5. So now I'm going to, if the leading coefficient is not a 1, don't forget you have to divide by 4. If you can simplify, great. If you can't, the denominator goes up. So now this is coming up over here. This will now be 4x minus 1. 4 divided by 4 is 1, so that gives me x minus 1 equals 0. So those are my factors, and then you can check it if you need to, if you don't believe me. But then you get 4x minus 1 equals 0, x minus 1 equals 0. I would add 1, so 4x equals 1. Divide by 4, so x equals 1/4. This one I would simply just add 1. Of course, you do have to check it. So plug in 1, 2 minus 1, 2 times 1 is 2, 2 minus 1 is 1, 1 raised to anything is going to be 1, and then 1 raised to anything is going to be 1. So 1 works. 1/4, so 2 times 1/4 would be 1/2. 1/2 minus, oh, we might have to write this one out. So let's check it. So we get 2 times 1/4 minus 1 to the 2/3 equals 1/4 raised to the 1/3. So I'd give you 1/2 minus 1, and then that'd give you negative 1/2 to the 2/3. So to kind of rewrite that, that is going to be the exponent. This is the index. So this is the cube root of negative 1/2 squared. And this right here would just be the cube root of 1/4. So if I look at this, I can see that this will end up being the cube root of 1/4 as well, because negative 1/2 squared would just give me 1/4. So without actually figuring out what the cube root of 1/4 is, I do see that they're the same answer. So x equals 1/4 will also work. Let's try one more of these, and then we'll do some what we call literal equations. So let's look at number 29. 29 says x to the 2/3 minus 25 over 49 equals 0. So first thing I'm going to do is isolate the radical, even though it's written as rational exponent. And then, so I'll add 25 over 49. That gives me x 2/3 equals 25 over 49. Now, since these are big numbers, I'm not going to try to cube it, even though you could. I'm going to rewrite this. Remember, this is an exponent is e over I, just like the last problem. So this is my exponent. This is my index. So this is the cube root of x squared equals 25 over 49. I guess it wouldn't matter. I'm going to have to do it anyways. All right, so the best thing I can do here is I guess I didn't have to do this step. So I'm going to go ahead and erase this step. You can if you want, it just looks cleaner. I'm going to cube both sides of these. And the reason is because if I don't like fractions, I can raise it to the denominator. So I now get x squared raised to the 3rd power here. So let's figure out what this is. So this would be 25 times 25 times 25, which is 15,625. And this is 49 times 49 times 49, which is 117,649. 117,649. And then now I can take the square root of this result. But don't forget, it can still be plus or minus. All right, so we'll just kind of do this separately. So I'll just do this. That gives me 343 on the bottom. And then I'll do 15,625 and do the square root of that one, and I get 125. So therefore, the answer to this one would be plus or minus 125 over 343. We could then take these fractions, plug them both in, but I don't feel like doing that. So I'm just going to let you know it does work, but do check it just in case. So the best thing to do is to square the number first and then take the cube root and see if you get 25 over 49 and give you, I'll do it with you. Tell you to do it, then I don't do it. All right, so this would be, so to check it, you would have to square 125 first. So 125 times 125. And then you would need to do the cube root of that. Oh, actually, is that a, oh, we might be able to do this. Let's do 125 divided by 343 to get this answer. I want to raise that answer to the 2 divided by 3. All right, and that will give me 0.667. So Fascinating. Oh, wait, no, sorry. That will give me the answer. So 0.510204, whatever that is. So let's just see what 25 over 49 is. 25 divided by 49 gives us the same answer. So when I subtract the two, I would get 0. So always check it. Now, because I squared them, the positive or the negative is not going to matter. So it's going to work out both ways. But there you go. All right. So those two, again, look complicated, but weren't so bad. The next parts are literal equations, and it's basically just solving the equations with just letters. So you were given the formula. So, sorry, let's rephrase that. Let's look at number 34. You were given the formula t equals 2 pi times the square root of L over G. So the formula of this gives the period t a pendulum of length L, and we want to solve for L. All right, so when I'm solving for a letter with a whole bunch of letters, I like to circle it to let me know this is what I'm trying to get by itself. Before I can get rid of the radical, I have to isolate it. So I'm going to divide both sides by 2 pi. And then also note when you're dealing with literal equations, you're not going to get a number out of it. You're just going to get another formula out of it. All right, so don't try to simplify it because you can't. Now that I got the radical by itself, I can then square both sides. You can isolate, you can go ahead and distribute this out. So this would be t squared and then 4 pi squared equals L over G because this will cancel. And then all I got to do now is just multiply by G. And what I do to one side, I must do to the other. So to find the length of the pendulum, it is just going to be t squared times G over 4 pi squared. I'm assuming t is the period. Yeah, times, I'm going to go with G as gravity. So the period squared times gravity divided by 4 pi squared would give you the length of the said pendulum. All right, so that's basically all you got to do. So you're just doing your regular work. You're just getting an equation out of it. Let's look at another one. Let's look at 35. All right, the formula now that's given is C equals the square root of A squared plus B squared. So this gives the length of the hypotenuse C of a right triangle, and we want to solve for the formula for A. So the first thing I need to do is get rid of the square root, which is now isolated. So I'm going to square both sides. So I now get C squared equals A squared plus B squared. Then I'll subtract the B squared because I always want to get rid of my addition and subtraction first. So C squared minus B squared equals A squared. Now I'm going to take the square root of this guy. Now, do watch out for this because when I take the square root, don't forget the plus or minus. So A would equal the plus or minus the square root of whatever C squared minus B squared gives me. All right, and so there would be your answer. All right, let's do one more, and I think you have everything that you need to be successful. So let's look at number 44. 44 says the total mechanical energy of an object with mass m at the height h in a closed system can be written as capital M, capital E, equal to 1/2. Oop, that's not a half. 1/2 times mv squared plus mgh. And then you are asked to solve for v, the velocity of the object in terms of the given quantities. All right, so again, I always need to isolate it. So I'm going to get rid of my addition subtraction first. So I get capital M times capital E minus lowercase m times lowercase g times lowercase h. And then I get 1/2 mv squared. So I don't like fractions, so I'm going to multiply this by 2. But then when I do that, I got to multiply this by 2. So I get 2me minus 2mgh. You just distribute. This would cancel, and I'm now left with mv squared. Now I'm going to divide by m. Okay, so I'm going to just take this whole thing, divide by m. And then I now have v squared equals 2me minus 2mgh over m. And then we'll take the square root. Again, we're not going to forget the plus or minus to this. So therefore, I get plus or minus 2me minus 2mgh over m equals v. Another way you could have also seen it is they would not have distributed the two. Maybe they left it like this as well. So you just write this here as well, but it completely doesn't matter. I wouldn't have distributed because I was thinking maybe we could cancel something. This looks cleaner, in my opinion. But I'm good either way. So there you go. So that's pretty much it for chapter 2, and everything that's going to be on the test from chapter 1 to chapter 2 you now have. So remember, the test opens up again on the 22nd. It is due by the 28th. So you have 7 days to take the test and upload your work. The practice test will again open up on the 19th, which is the Friday, to give you some 3 days prior to review everything. Again, practice test is not a grade, but it's a review basically. It basically shows you everything that's going to be on that test prior to it being on the test. It's not timed. You can pause. You can do whatever you want on that one. The real test has lockdown browser, so make sure your computers are compatible for it. I expect you to have that ready to go by the 22nd. Don't wait until the last minute to check it or the last minute to take the test and then you tell me that you have technology issues, because that's just as an excuse as my dog ate my homework these days and there would be no leadway on it. You had plenty of time and plenty of warning. The place to upload your work will be in Blackboard. So do make sure you go back to your Blackboard, log in, and there will be a place for it right below, probably right above all the videos for the week, because there will be 4 videos posted for chapter 3. That homework will also be due Sunday. So again, utilize your time management skills. So there'll be a place to upload it. Make sure you upload it. If you have struggle doing it, by all means, let me know. Do make it one single PDF, not like one page, but like one attachment. I don't want 52 different attachments for all your work. You will have 2 hours to take a 20-question test. I doubt you need 2 hours, but I'm going to give it to you anyways. But there is no pause, so make sure you give yourself 2 hours window, just in case you do need the full time. Other than that, there's not much more to it. It's pretty straightforward. There's no tricks on the test. It's everything we've seen in these videos, everything you see on your homework, anything that could be on the practice test, even anything in the book. So it's not coming out of left field. Everything is at your fingertips to study. Other than that, that's about all I got. So if there's any more help you need with anything, please feel free to email me and let me know. Other than that, I will see you in the next video. Bye for now, and good luck on test 1.